All right, here we go. All right, so what I was hoping you would do and be able to do is use your two triangles. So I'm going to go ahead and label them now. The 30-60, my 45-45, and you're going to use your 4 points on the unit circle. So when I do, and I ask you to do cosine, so the cosine at 0 would be 1. The cosine of pi over 6, that's radical 3 over 2, so that's your 0.866. Pi over 4 is radical 2 over 2. Pi over 3 is 1/2 or 0.5. Pi over 2 is 0. Then when you're going around the circle, 2 pi over 3, that's a reference angle of 60 degrees, but it's in the second quadrant, so that's your negative 1/2. This is negative 0.7071, negative 0.866, negative 1. And hopefully you could see this pattern as you went around. 7 pi over 6, that's 30 degrees in. So that's negative 0.866. This is I'm now in the third quadrant. This is negative 1/2. This is 0. This is a 60-degree reference angle, so it's positive 1/2, 0.7071, 0.866, and back again around at 1. Okay? So if you're struggling with these values, pop into either Math Lab or come see me tomorrow in office hours, and I can kind of slow that down, but I'm assuming at this point we know how to find those around the circle. So 0, 1, then here's the cosine curve if you plot those. Now, this is just one period length, so the period length for cosine is 2 pi. And if I continue this to the left, just a little bit, my domain, this is going to oscillate forever to the left and to the right. So the domain is negative infinity to infinity. And what's my range? Negative 1 to 1. Okay, the range are the y values, the domain are the x values. That's a bracket there. So it's negative 1 to 1. Now we've talked about even and odd functions, so let's talk about it again. Is cosine even or odd? It's even. Why is it even? Like, how do we know it's even? There's a couple different ways we know. Yeah, Eli? Yeah, it's symmetric with respect to the y-axis, right? The y-axis. And think about it, like if you ever get mixed up, think about an even function y equals x squared. That is symmetric with respect to the y-axis, so that's how you know. The other thing we know about even is f of negative x equals f of x. So it's good just to review this. All right, so now, instead of doing this huge table, but I wanted you to see, like if you were estimating 0.866 and 0.701, do you see how it is sort of flattened up around like the maximum and the minimum? It is kind of, not flat, but you know, there's a lot more going on up there. So then we're going to do our 5 key points, or our 5 main points. So let's look at the sine function. And in the table, we're not going to go crazy here, and we're just going to do these 5. So let me pause a moment, and I want you to use what you know about the unit circle. So here's the beautiful connection to why I'm giving you these quick quizzes. If it's taking you forever to figure it out, that is a secondary skill. So I'm actually trying to help you by getting you to know these and to be able to figure them out quickly, because now we're going to be graphing and we need to know those values. And we need to know them rapidly. Otherwise, you're just constantly just spinning your wheels trying to figure it out. All right, so use a circle or your triangles and get the y values. So the sine of 0 is 0, sine of pi over 2 is 1, the sine of pi is 0, sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. So let's go ahead and go every other tick. So the sine starts at 0, 0, goes up to 1, 0, negative 1, 0. If I go ahead and continue this just a couple more ticks onto the left, just so we can see a nice picture. The domain is negative infinity to infinity. My range is negative 1 to 1. Now, we talked about this earlier. So obviously this one's not even, it's going to be odd, but this had what we called origin symmetry. And I want you to take your paper, flip it upside down, and look at the sine curve. It looks identical if I've rotated it around the origin. So the sine is odd because it's symmetric with respect to the origin. Also, a neat feature of odd functions is f of negative x equals the opposite of f of x. All right, so this was just a quick recap on the graph of cosine and sine. Last year in Algebra 2, we did a lot of work with our transformations, so we're going to review them today and tomorrow. We're going to do sine and cosine and tangent. Then we're going to move into the other three reciprocals. Honor students, did you do reciprocal graphing last year? Okay, regular. I don't think we did those. Or did we? I can't remember. All right, so let's flip the page when you're ready. And a function is a sinusoid if it can be written in the form f of x equals a sine the quantity bx plus c plus d. Since cosine functions are themselves translations of the sine functions, any transformations of a cosine function is also a sinusoid by the above definition. So I want you to, let's go back up and look a moment. If the sine curve goes through the origin, what kind of a shift would we have done to get the cosine graph? I'm not going up or down. So from the sine, you could move it, would you be moving the sine curve right pi over 2? No. You could move it left pi over 2. I could take this graph and shift it left pi over 2, and then that's cosine. There's actually infinitely many shifts I can do. All right, the amplitude is the absolute value of A when it's in this form. Another way to look at amplitude, it's half the height of the curve, or 1/2 your maximum minus the minimum. So in example 1, we want to find the amplitude, and I want to show you, so we're going to make just quick sketches here. But if I've got my 5 main points, and you are going to get tired of writing them, but the good news is you will know them like the back of your hand. So I'm going to do the parent function again. And I'm okay if you label just every other tick on the x-axis. So cosine starts, I like to say that cosine starts at the a value. So my amplitude is 1 on the parent graph. move through this. I like to do mapping notation. That's the way I like to do it. You don't have to do the mapping notation. If your teacher or if you go to Math Lab, you can take and do like the translation shifts and do it that way. There's other ways to sort of think about it, and I will ask you to share, like as we're doing them, and especially when they get super complicated, if you will share that you're just taking the axes and shifting, if you want to share that, so that if some students will like that and some will like mapping. So, you know, and I'll kind of show you both ways, but then I'm going to lean more towards the mapping. That's just how my brain is wired. So, so for letter B, I can tell that the amplitude is 1/2. And so if I'm going to do the mapping notation, it's going to go like this. Nothing has happened to the x because I didn't do anything inside, but I'm going to map it to x comma 1/2 y. So what that means, and I'm kind of going to do this nice and slowly here, I didn't do anything to my x value, so I used the 5 key points. And I'm going to ask you for your 5 key points. So if you're going to do it another way, that's okay, but you have to be able to identify your 5 points. Here, I'm going to take all the y values of the parent function and multiply the y value by 1/2. So it's 1/2, 0, negative 1/2, 0, 1/2. So then this is, again, at your A value. Now the period for each of these is 2 pi. I didn't adjust the period yet. Is this coming back to you? You guys remembering this a little bit from Algebra 2? If you ever feel like you are just completely lost, try to watch the video a second time, or get into Math Lab or do office hours, or, you know, ask some classmates, hey, can we get together? I'm also happy if I don't have any meetings in the morning, I can meet you at 7:45 if you just, you know, email me. I'm happy to do that. All right, on the third one, what's my amplitude? Is it 3 or negative 3? Why is it not the negative 3? Because that's a negative 3 out front. It's absolute value. Why is it absolute value? It's a height. It's a distance, right? It's a distance, and distance can't be negative. All right, so my mapping notation is going to go every ordered pair. Again, I didn't do anything to the x, but here's where the negative 3 comes in. It's in my mapping notation. So I didn't do anything to the x value, so I've got my 5 key points that I'm starting with the same x values. But on this one, I'm going back to that parent function, and I'm going to multiply all the y values by negative 3. So it's negative 3, 0, positive 3, 0, negative 3. What does the negative do graphically? It flips it, okay? We can call that a reflection over the x-axis. So that just means I plot, when I do cosine, I just start at my a value. So if my a is negative, I start down at that negative value. So here's 0, negative 3, pi over 2, 0, pi is positive 3. So it's like you have reflected. All right, the period length. is going to be 2 pi divided by the absolute value of b. So we're going to do the same thing now, but we're going to practice with the sine curve. So we will do the parent function, y equals sine x, so that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. So sine starts at 0, 1, 0, negative 1, 0. The amplitude is 1 on this one. So here's my parent function. Alright, so in letter B, what's my amplitude here? 2. Alright, to do the period length, you're going to take 2 pi and divide by the b value. The b value is 1/3. So the period length is 6 pi. And then let's do the mapping notation. What we did last year is we set it equal to m, or you could do a smiley face. So what you do is you take the inside equal to a dummy variable, okay? So you could make it m, you could do the smiley face. So then my mapping is going to go like this. X comma y maps to 3 times x comma negative 2 times y, okay? So let me go over that one more time. Let you write it down. When you go to do your mapping notation, you set the inside equal to a dummy variable. So I called it smiley face. You can call it m, whatever you want. And then you solve for that x. So 3 times the dummy variable is how I'm transforming it, okay? Did I answer did you have a question, Jackson? No? All right, so here we go. Let's do our XY table. And now I have to take every x value and multiply by 3. Okay, I'm going to take every x value and multiply it by 3. So 0 times 3 is 0. Then that's 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. So again, my mapping notation tells me how to get the points. So I took every x value of my parent function and multiplied by 3, and now I'm going to take the y values and multiply by negative 2. So that's 0, negative 2, 0, positive 2, 0. So now you got to stop and think about how you're going to do your ticks here. Because I need to get all the way to 6 pi, but I need some pi over 2's. I made this kind of long. So 6 pi is 0, 3 pi is 0, and at 0 is 0. Then here's 3 pi over 2 is down at negative 2, and then 9 pi over 2 would be up at positive 2. You notice they're like 3 ticks apart? Try to think of it like that. range on this one? What are the y values? -2 to 2. Okay. All right, let me pause and I want you to try letter C. Okay, try letter C. Okay, do as much of part C as you can. So what I'm passing out is the homework, but it's not due tomorrow. This will be due on Friday. So you might want to just write on the top of it, due Friday. But get part way done today. I'm going to erase some of this. For your mapping notation, are you getting x over 2, comma 1/3 y? You getting that?
Why do you do this?
You need a dummy variable, like it can be any letter you want, but I figure if we use like a y, I don't want to mix up x and y. So it's just a dummy variable because you're trying to reverse the inside. It's going to end up being called our phase shift. Alrighty. Now, are you guys okay with this? When you take pi over 2 and you're dividing by 2, that's pi over 2 times 1/2. That's where I'm getting the pi over 4. My amplitude is 1/3. And what do you guys get for the period length if you take 2 pi divided by the b value? You just get pi. So you want to take time and look at your table. This one worked out pretty nicely. In terms of my values, so I had 0, 0. This is pi over 4 went up to 1/3. So this is what we call a vertical shrink. All right, questions so far on amplitude and period? All right, let's try and get the phase shift in here. It says the phase shift, if it's in this form, it's just -c over b. So let's look at example 3. So what you're going to do is we can do the amplitude is 1. My period is going to be 2 pi over 4, or pi over 2. Nothing is happening to the y value, okay? There's nothing in front and nothing following it. But I do have a phase shift. So I'm still going to call this my dummy variable here to get my shift. Oops, I don't know why I called that 5. That's 4x equals the smiley face minus pi, and then x, I'm going to divide by 4. So my mapping is going to look like this. I'm going to take every x value, divide by 4, and subtract 4. Now my phase shift, okay, the phase shift is c over b. So that's negative pi over 4. So what that means is I am shifting left pi over 4. Now my parent function, either you know them or you write them out. I personally write them out. I told you were going to know these really well. So if I go back to the parent function, y equals sine x, and then I do my mapping notation on it. So this is just going to be a lot of fraction work. So I'm trying to go slowly here for you. So if I plug in 0, I get 0 minus pi over 4, so that's minus pi over 4, and I did nothing to the y value, so if you want, just fill them in. Now what's going to happen when I do pi over 2 divided by 4 minus pi over 4? Okay, these are just some yucky fractions, and unfortunately, we've got to deal with them. Okay, so I'm putting every point in as the x. So this says take that x value divided by 4. So that's pi over 8 minus, and let's just build the common denominator. So that's negative pi over 8. Let's do the next one. If I plug in pi, hey, what's pi over 4 minus pi over 4? 0. Oh, thank goodness. Now let's do 3 pi over 2 over 4 minus pi over 4. Now you will notice a little pattern, right? If you're catching on to the pattern, do you see that these are going up by pi over 8s? If you catch the pattern, you don't need to do this stuff. You can just keep following. So if I go 1 more pi over 8, what value is that? Pi over 4, right? All right, so let's go by pi over 8s. So every other one will be a pi over 4. Now 2 pi over 4 would be pi over 2, right? So negative, that's negative pi over 4. So that's 0. This went up to 1, 0, negative 1, 0. So do you see, I've taken the sine curve and I've just moved it left pi over 4. All right, let's try to get the next one in, then we'll stop. So here we go. Letter B. I've got an amplitude of 1. The period is going to be 2 pi divided by 2, which is pi. I have a phase shift. It's the C value divided by the B value. So that's pi over 6. Now, does everybody understand why am I putting positive pi over 3 in for C? Why am I doing that? Yeah, because it's minus C. Okay, so you're always doing the opposite sign. All right, let's do our little mapping. So you're going to do 2x minus pi over 3 equals the smiley. So add pi over 3. And then when I go to divide by 2, Hopefully you can do this with me. That's pi over 6, okay? You should start getting the hang of that fraction stuff. So here's my mapping. I'm going to take the x values, divide by 2, and add pi over 6. I'm doing nothing to the y values. We'll do that tomorrow. This one is cosine. And I hope you can begin to appreciate a little bit more like why I'm spending the extra time on the unit circle. Like, we have got to know those values. All right, I'm going to pause, and I want you to try to get your table. The y values are the same, so I don't need to worry about those. But let me pause and let you plug each parent value for x into the mapping. So it's, again, it's unfortunate we have some fraction work to deal with. But again, if you can catch, I usually do at least the first 3 points, and if I notice the pattern, then I can go. So that might help a little. Did you guys get 5 pi over 12 for the second one? All right, good. And please, please, please reduce. So the third one, I'm getting 4 pi over 6, so that's 2 pi over 3. And then I got 11 pi over 12. And then 7 pi over 6. So if you have to go by 12ths, so if I go by 12ths, so then at pi over 6, that's going to be 2 pi over 12. That's up at 1. Then 5 pi over 12 is 0. So do you see they're 1, 2, 3 apart? 1, 2, 3. That kind of helps. All right, so tonight I'd really like you to try example 4 on your own. Okay, try example 4 tonight, and then look at the homework and do as many as you can. Let me pause my video. And watch the video again if you need to, okay?